These problems are complex fractions. What we'll need to do is we'll need to use either what was referred to as method 1 in the book or method 2. And I'll switch back and forth between these two. But for this first one, what I want to point out is this is going to be one where I'm going to use the method where we take the 5y, because it is a common denominator for both of these fractions, and multiply by it. What that gives us is I'm going to multiply by 5y, and the 5y will cancel out with this 5y, and so that'll leave me with 3. But I also have to multiply it here, so I'll end up with 40y. Now I'll multiply and distribute the 5y into both terms here. Again, it's going to cancel, and I'll have a 3. And when I multiply here, this will be then minus 40y. So I end up with 3 plus 40y divided by 3 minus 40y. And this one will also be kind of simple the way we go through this, is I'm just going to take a look at this denominator here. This is an m minus 2 and an m plus 2. And you can see in the case here where we had 5y as being a common denominator for the top and bottom fractions, what I have is I'll multiply both top and bottom here by the m minus 2 and the m plus 2, and the m minus 2 will cancel out here, and the m minus 4 will cancel out here. So what we'll do is have m minus 2 times m plus 2 and m minus 2 times m plus 2 here. Now m minus 2 and m minus 2 cancels, and I have m plus 2 times m plus 2. Here, the m minus 2 and the m minus 2 will cancel, m plus 2 and m plus 2 cancel. So everything's gone except for this 2m plus 4. Now you would think you could be done at this point, but we've got one more step. Factor out a 2 from this, and that'll leave you with 2 times m plus 2. And you can see what happens is the m plus 2 cancels out with m plus 2, leaving you with just m plus 2 over 2. For these last three questions, each one of these is asking for the equation of a line. What we need for an equation of a line is to use the point-slope method. We need to have a point and we need to have a slope. In problem number 3, all the information is given to us. So we'll just plug in all the values into what we have for the point-slope equation, which is y minus 1 is equal to 4 times x minus 5. Now, this could be our solution, but we also want to have these all converted into the slope-intercept form. So what I'll do first of all is distribute the 4x through and then solve for y. And so we have our answer in the slope-intercept form. For problem number 4, what we have is a slope of 0. Now when we have a slope of 0, this means that what we have is a horizontal line. Horizontal line means that we have just y equals, so the equation for this is just y is equal to negative 4. Oh, how about positive 4? Sorry, negative 4. For the last three problems, we'll be using the point-slope form of the equation. In problem number 3, we are given a point and a slope, and so this will just go right into the equation. We'll have y minus 1 is equal to 4 times x minus 5. We'll distribute the 4 and end up with 4x minus 20 and y minus 1. We'll then want to get this into the slope-intercept form, and so we'll want to solve for the y. Solving for y, we have y is equal to 4x minus 19. This is just the easier form to express these in. In problem number 4, what we have is a slope of 0. And whenever we have a slope of 0, this means we have a constant line. And so what this means is that we just have the y value of -4. So the equation for the line here is y is equal to -4. In problem number 5, we're given a point, and then we're given a line. We have no idea what the slope is, but what we need to do is find the perpendicular slope. To find the perpendicular slope, we're going to need to take this original line and get it into the y equals mx plus b format. So we have 2x minus 3y is equal to 1, minus 3y is equal to minus 2x plus 1. Dividing everything by -3 to get the y by itself, we'll end up with y is equal to 2/3 x minus 1/3. Now what we get out of this is in the form y is equal to mx plus b. The m we have now identified as 2/3. In the original problem, we were asked for the perpendicular slope. Perpendicular slope is taking the negative reciprocal of this value. So what we have here is -3/2. Once we have the -3/2, we now have the slope that will go through this line. So we're going to plug these values back into the slope-intercept form. So y minus 8 is equal to -3/2 x minus a -4. Okay, so our first step again is to distribute the -3/2. So we'll have -3/2 x. And now look, we have negative, negative, and negative. 3 negative signs means that I'm still going to end up with a negative. 2 goes into 4 twice, leaving me with a 2. 2 times 3 is going to give me a -6, y minus 8. Get the y by itself, and we'll have it into the slope-intercept form of the line. And so there we have our problem.